Every disaster movie tells us the same story. There's always a way out. An asteroid is deflected, a virus is cured, humanity adapts. But what if the real extinction event doesn't come from space? What if it comes from beneath your feet? Right now, under places like Yellowstone, Campi Flegrei, and Toba, sits enough pressure to darken the sky, freeze the planet, and collapse civilization, not in centuries, but in months. No impact, no warning, no heroic solution. Tonight, we're asking a question most people avoid. Not how a supervolcano erupts, but why, if it does, Earth as we know it may not survive at all. Before we go any further, let's be clear about something. This isn't science fiction. This isn't a Hollywood worst-case scenario designed to sell tickets. And this isn't about predicting when a supervolcano will erupt. This is about understanding limits, the physical limits of Earth's systems and the biological limits of survival. Everything in this video is grounded in well-established fields: volcanology, climatology, atmospheric chemistry, and the geological record preserved in ice cores, ocean sediments, and extinction layers. Scientists don't argue over whether supereruptions have happened. They argue over how close we may be to the next one and how severe the consequences would be. When researchers study events like the Toba eruption roughly 74,000 years ago, they're not speculating. They're measuring ash layers thousands of miles thick, sulfur signatures locked in Antarctic ice, and sudden population bottlenecks that appear across multiple species, including early humans. Organizations like the U.S. Geological Survey and NASA openly acknowledged that a VEI-8 supereruption would be globally catastrophic. What's less discussed is how catastrophic and how quickly modern civilization would unravel once the atmosphere itself becomes hostile to life as we know it. And here's where skepticism matters. Reassuring headlines often focus on probability. Supervolcanoes are rare, but rarity is not the same as safety. Airplane crashes are rare too, yet no one designs planes assuming failure is impossible. So the goal here isn't fear, it's clarity. If we want to understand whether Earth could survive a supervolcano, we have to stop thinking in terms of survival movies and start thinking in terms of planetary systems, systems that don't care about technology, borders, or optimism. When most people hear the word volcano, they imagine a mountain lava flowing down its sides, ash drifting into the sky, maybe an evacuation zone drawn on a map. A supervolcano is not that. In fact, calling it a volcano at all is misleading. A supervolcano is a collapsed region of Earth's crust, sometimes dozens of miles wide, sitting on top of a magma reservoir so large it rewrites the rules of geology. There's no cone, no warning plume, just a vast, pressurized system sealed beneath kilometers of rock. When it erupts, it doesn't erupt. It fails. The crust fractures across massive areas, releasing energy equivalent to tens of thousands of nuclear weapons, not as a blast, but as sustained atmospheric destruction. This isn't an explosion you outrun. It's a planetary-scale release of ash, gas, and heat. On the Volcanic Explosivity Index, or VEI, most historic eruptions rank between 3 and 6. A supereruption is a VEI 8. A jump so large, it's not linear, but exponential. Each step up represents 10 times more material. That means a supervolcano doesn't produce more ash. It produces continental burial. And this difference between disaster and system collapse is where survival narratives start to break down. If a supervolcano erupts, the first thing to fail is not governments, or power grids, or economies. It's air. Within hours, ash clouds spread across thousands of miles. Not soft ash, but microscopic shards of volcanic glass. It clogs lungs. It shreds jet engines. It collapses roofs under sheer weight. Entire regions lose visibility, sunlight, and breathable air almost simultaneously. Evacuation sounds comforting until you realize transportation depends on engines, electronics, and clear air. Ash disables all three. Airports shut down globally. Roads become impassable. Emergency response collapses under scale alone. Water systems fail next. Ash contaminates reservoirs, rivers, and filtration systems. It doesn't dissolve, it accumulates. Pumps grind to a halt. Cities don't run out of water. They lose the ability to process it. And then there's food. Within days, livestock suffocate. Crops are buried or poisoned. Supply chains already fragile break permanently. Modern cities don't store food for months. Most store it for days. This isn't chaos. It's physics operating faster than coordination can respond. The ash is only the beginning. What follows is something far more dangerous. Volcanic winter. Supereruptions inject massive amounts of sulfur dioxide into the stratosphere. There, it forms sulfate aerosols that reflect sunlight back into space. Not for days, not for weeks, for years, global temperatures plunge. Models suggest drops of several degrees Celsius worldwide enough to devastate agriculture everywhere, even regions untouched by ash. Summer disappears. Growing seasons collapse. Photosynthesis slows or stops entirely. And here's the critical point most people miss. Modern agriculture is optimized, not resilient. We rely on narrow temperature windows, predictable seasons, global fertilizer production, and just-in-time logistics. Remove sunlight, and the system doesn't degrade, it fails. Within months, global famine begins. Not because food is unevenly distributed, but because it can no longer be produced at scale. This is the moment Earth doesn't just suffer a disaster. It enters a biospheric shutdown. Even if some life survives on land, the oceans, Earth's largest life support system, begin to unravel. Acid rain increases as sulfur compounds fall back to the surface. Ocean pH shifts rapidly. Phytoplankton, which produce over half of Earth's oxygen, begin to die off. This is not hypothetical. It's documented in past extinction events. When phytoplankton collapse, the oxygen cycle destabilizes. Food webs implode from the bottom up. Fish stocks vanish. Marine ecosystems crash globally. At this point, the question is no longer whether humans survive. It's whether complex life does. Earth doesn't explode. It suffocates. At this point, the usual answers appear. Bunkers, seed vaults, underground cities, space colonization. But technology doesn't fail because it's weak. It fails because it's interdependent. Bunkers need power. Power needs fuel. Fuel needs infrastructure. Infrastructure needs stable climate and logistics. Seed vaults preserve genetics, but genetics don't grow without sunlight, soil, and temperature stability. As for space, humanity can't evacuate billions of people off a planet on short notice, especially when launch systems themselves are grounded by ash and atmospheric disruption. Technology scales beautifully in stable environments. It collapses in unstable ones. And a supervolcano creates instability on a planetary level. At this stage, something uncomfortable becomes clear. Earth doesn't need to be destroyed to become unlivable. It only needs its systems pushed past recovery thresholds. And that raises the most unsettling questions of all. Not about if a supervolcano erupts, but why we're so confident we'd survive if it does. By now, the question isn't whether a supervolcano would be dangerous, it's why we talk about it so calmly. Geologically speaking, supereruptions are rare, but they are not myths. Over Earth's history, they appear with uncomfortable regularity, not on human timelines, on planetary ones. And that distinction may be the most dangerous assumption we make. Because when we say something is unlikely, what we often mean is inconvenient to think about. No early warning system can guarantee years of notice. Magma chambers don't follow schedules. Some past eruptions show centuries of buildup, others show signs only months before failure. And unlike asteroids, there is no deflection strategy, no intervention, no second attempt. So why does public discussion focus almost entirely on reassurance? Part of it is psychological. Humans are wired to discount slow, invisible threats. We evolved to fear predators and storms, not pressure building miles beneath solid rock. Another part is cultural. Our survival stories depend on ingenuity saving the day. We prefer narratives where technology wins, but planetary systems don't negotiate. There's also a quieter question, one rarely asked out loud. If the consequences are truly unsurvivable at a global scale, how should institutions even communicate that? Do you prepare people for something they cannot stop? Or do you minimize it to preserve social stability? And then there's the deepest tension of all. Earth has recovered from supereruptions before. Life returned. Ecosystems reassembled. But that recovery took tens of thousands, sometimes hundreds of thousands of years. So when we say Earth survives, what do we actually mean? The planet or us? Because survival isn't binary. There's a difference between a world that continues to exist and a world where civilization, memory, and continuity endure. And that distinction may be the most uncomfortable truth buried beneath our feet. By now, one thing should be clear. A supervolcano doesn't need to wipe Earth clean to end the world we recognize. It only needs to disrupt the systems that make complex life and civilization possible. Sunlight, climate stability, oceans, agriculture, remove those, and survival becomes a temporary condition, not a future. And this isn't about doom. Understanding limits is not the same as surrendering to them. Human history is shaped by a dangerous habit, confusing improbability with impossibility. We assume that because something hasn't happened in our lifetime, it exists safely outside our concern. But geology doesn't care about generations. It operates on deeper clocks. The uncomfortable truth is this: Earth is resilient, but not gentle. It recovers eventually. Life returns eventually. But recovery does not guarantee continuity, and resilience does not promise mercy. So maybe the real question isn't whether we could survive a supervolcano. Maybe it's why we measure survival so narrowly. If thinking about this makes you uneasy, that's the point. Curiosity often begins where comfort ends. Skepticism isn't cynicism, it's a refusal to accept easy stories when the evidence suggests something harder. And if there's any preparation worth making, it's not bunkers or escape plans. It's learning how to think clearly about risks we can't outrun, systems we depend on, and a planet that doesn't need our permission to change. Because the most dangerous myth isn't that Earth is fragile, it's that we are untouchable.